calculate the price of a stock. Here are some key concepts and skills in this lecture. I will explain how stock prices depend on future dividends and dividend growth rate. And I will show how to calculate the value of stock prices using multiples. And there are a few different ways corporate directors are elected to office. So we look at different ways how they are elected. And we'll define how the stock markets work. So we look at stock markets in the world. And this is the chapter outline. We'll study how to calculate the value of common stocks. So we'll calculate the price of a stock. And then we'll look at a few characteristics or features of common stocks and preferred stocks. And then we'll look at the stock markets in the world. Okay, before we calculate the price of a stock, we have to look at the cash flows of a stock. Usually cash flows are the cash flows for the stockholders, the owners of the stock. So if you buy a stock, and then you can receive cash in two different ways. One is dividends. So the issuing company of the stock should pay dividends to the stockholders. So as long as you keep the stock, then you can get dividends from the company. Second, you may sell the stock to somebody. So if you sell your shares to somebody in the market or back to the company, then you'd get the price of stock at the moment of trade. So there are two ways. If you keep the stock, then you can get dividends from the company. Or if you sell the stock, then you can get the price of the stock at that moment. So similar to bonds, the price of a stock is the present value of expected future cash flows. So first, we have to estimate the future cash flows and then calculate the present value of these expected cash flows in future time. Then the present value is the price of the stock. Then how do we generate the cash flows of a stock? So let's start with one simple example, one period example. So here we only consider one period from time 0 now to the next time 1. So there is only one period. And suppose you are thinking of purchasing a stock and you expect the stock to pay a $2 dividend in 1 year, after 1 year. So there is a cash flow, $2 like interest or coupon from a bond. So $2 dividend. So dividend is like interest or coupon in bond. And you believe that you can sell the stock for $14 at the time 1 plus face value, like a face value. The future value of a stock is $14 and you need some discount rate. So the discount rate for a stock is called required return. So if you require a return of 20%, then this is rate of discount or required return. So this is R, discount interest rate. Then what is the maximum amount you would be willing to pay for the stock? So you want to purchase the stock today. So what is the maximum price? What is the maximum value? That's the price of the stock. But it is easy to calculate the present value of future cash flows, dividend plus future value of the stock. So we discount $2 and future value of the stock, future price of the stock, using interest rate 20%. So $13.33 is the present value. Okay, so this is the price of the stock today. But here, we have dividend at time 1, and we have the price of the stock at time 1. So the current price is simply the present value of dividend plus future price of the stock. So simply discount future value of dividend and stock price divided by 1 plus R. So I want to write down this like this way. We discount dividend with some interest rate plus future value divided by 1 plus R. It is very simple. So again, we have the same example as before, but we consider 2 time period. So right before, we consider $1 dividend at time 1, a $2 dividend at time 1, $2, right? Yeah. Now, if you decide to hold the stock for 2 years, you do not want to sell the stock at time 1, but you want to hold the stock 1 more year until time 2, then you would get the dividend at time 2, and the dividend is $2.1 plus the final value, the future value at time 2. The future value at time 2 equals $14.7. So this is the stock price at time 2. But anyway, what is the price of the stock today? So that's the question. But again, it is simple. The present value at time 0 is the price at time 0. So we discount the dividend with some interest rate for 1 year, and then we discount the interest or dividend at time 2, but we need discount for 2 years, and then the future value of the stock at time 2 divided by interest rate for 2 years. So plug the numbers here. So first dividend $2, interest rate 20%, second dividend at time 2 $2.1 plus the price at time 2 $14.7 divided 1 plus interest rate to the power 2. So we have the same price as before. In the previous slide, the price of the stock, the present value was this number, 13.33, the same price. So because this is the same stock. Okay, we have the same stock as before, but we are consider 3 period time example. So 1, 2, 3. So you want to keep the stock, you want to hold the stock for 3 years and sell out at time 3. Then what is the present value at time 0? This should be the same as before because this is the same stock. So at time 1, we have dividend $2. At time 2, the dividend was 2.1. Is that correct? Yeah, $2.1 at time 3. The dividend at time 3 equals 2.205, and the price at time 3, the future value of the stock at time 3 is this number, 15.435. So the present value is very simple. So the present value is simply dividend after 1 year, and then dividend at time 2. So we need 1 plus R to the power 2. Dividend at time 3, discounted by interest rate for 3 years. And then future value of the stock at time 3. So we have to discount for 3 years. So like this way, you can calculate the price of the stock. So D1, D2, D3, and P3. So we have the same price as before because this is the same stock as before. The same price, $13.33. That's the present value, the price of the stock at time 0 now. So like this way, we can calculate the price of the stock. So you could continue to push back the year in which you will sell the stock. So you can extend the period, like 2 years, 3, 4, 5, 6, 8, and so on. And then you would find that the price of the stock is really just the present value of all expected future dividends. This means what? As you know, the price was dividend divided by 1 plus R plus P1 dividend 1 plus divided by 1 plus R for one period model. But if we extend for 2 years, then simply it was this one. So if we sell the stock at time 2, then we have this model. But we can extend this model again and again infinitely many times. So here t goes to the infinity, then the price of a stock is simply d1 divided by 1 plus r, d2 1 plus r to the power 2, d3 divided by 1 plus r to the power 3, d4 divided by 1 plus r to the power 4, plus, and so on. This means that we hold the stock for many, many years, infinitely many years. Actually, we keep the stock forever. So, the stock price is simply the present value of all expected future dividends. So, the key point is the future dividends. So, how can we estimate all future dividend payments? So, if we have all of future dividend payments, then we can calculate the price of the stock. So, the price of a stock is simply the summation of future dividend at any time t divided by this number, and we add up from t goes from 1 to infinity. So estimating dividends is the key point when we calculate the price of a stock. So let's consider a few special cases. The first simple case is this one. Constant dividend. This means that the dividend at any time t is the same, a constant number. So the company will pay a constant dividend forever. So the dividend at any time t is the same dividend. And this is like preferred stock. And the price is computed using the perpetuity formula. So we have the perpetuity formula in the previous lecture. Another special case is this one, constant dividend growth. And the amount of dividend will grow with constant percentage rate. So the company will increase dividend by a constant percent every period. So here at current time we have some dividend, and then at time 1, the dividend will be increased by some constant rate, G. So here G means growth rate. And at time 2, we increase this again by some constant growth rate. So 1 plus G times 1 plus G, so power 2, like this way. So we increase the dividend each year by a constant growth rate. And the present value, the price, is computed using the growing perpetuity model. Actually, we have the formula for the growing perpetuity model in the previous lecture. Another a little bit complicated model is supernormal growth model. And here, dividend growth is not constant. Here we assume that dividend growth rate is some constant rate. But here, this rate is not constant. It may change over time. So dividend growth is not constant initially, but after some years, the dividend growth settles down to constant growth eventually. So there may be some different growth rate, like G1, G2, and so on, but eventually we have some constant growth rate. And the price is computed using a multi-stage growth rate model. But anyway, the price is the present value of future payments. Okay, let's consider zero growth model, zero growth dividend model. Yeah, zero growth means that growth rate of dividend equals zero. So dividend is always a constant number. So if dividends are expected at regular intervals forever, then it is a perpetuity. And the present value of expected future dividends can be found using the perpetuity formula. But we have this formula in the previous lecture. So if we have constant dividend at time 1 to 3 forever, then the present value at time 0, the price of the stock, is simply D divided by interest rate. So we have this perpetuity formula. Suppose a stock is expected to pay a 0.5 dividend every quarter, not every year, and the required return is 10% with quarterly compounding. So usually rate is annual rate. And then what is the price of this stock? So in 1 year, there are 1, 2, 3, 4 dividends, $0.5, $0.5, $0.5, $0.5, and so on. So using this formula, perpetuity formula, present value is simply dividend divided by interest rate. But you should be careful about this interest rate. This is annual interest rate. So the quarterly interest rate is 10% divided by 4. So we have this answer. Okay, then next, let's look at a little bit complicated model, dividend growth model. So here, we assume that dividend would increase with constant growth rate. Here, at time 0, we assume that the current dividend is D0, and then at time 1, D1 is simply D0 times 1 plus growth rate. At time 2, the dividend at time 2 is simply D1 times 1 plus growth rate, but we know that D1 is D0 times 1 plus G. So we have 1 plus G squared, like this way. So at any time T, the dividend at time T equals D0 times 1 plus growth rate to the power T. And the present value of these dividends is D1 divided by 1 plus interest rate, D2 divided by 1 plus interest rate to the power 2, and so on. But here we assume that D1 is D0, 1 plus G divided by 1 plus R. We already know D2 is D0 times 1 plus G to the power 2 divided by 1 plus interest rate to the power 2, and so on. So at time 0, we have the present value here. But here we do not add D0. We delete D0 at time 0 because D0 is already paid at time 0. And we consider the price right after the payment at time 0, right after the time 0. So it is not 0, but it is time right after the time 0. So usually 0 plus. So right after the dividend payment, right after the current dividend payment, we calculate the future value of future dividends. Because present value means that we discount the future values. That's why we delete the first dividend, because the first dividend is already paid at time 0. And right after time 0, we consider the price right after the time 0. So we consider the dividend from time 1, not from time 0. Dividend at time 0 is already paid at time 0. But anyway, we have to calculate this infinite summation. But using the algebra from high school mathematics, we can find the solution. The present value is dividend at time 1 divided by interest rate minus growth rate of dividend. Just look at this number, D1, not D0. And D1 is previous dividend times 1 plus growth rate G. Sometimes D1 is given directly, but sometimes the current dividend rate, just paid dividend D0 is given. Then we have to multiply 1 plus G to find D1. So you should be careful about this time D1, the next dividend, because present value is the discount value of next future values. Okay, let's solve an example. It is about dividend growth rate model. Suppose a company just paid a dividend. Here, just paid means current time 0. They pay a dividend at current time 0. They just paid the current time dividend, and it was $0.5 per one share. So just paid means that the current dividend, not the next year dividend. And it is expected to increase its dividend by 2% per year. So this is growth rate of dividend. And if the market requires a return of 15% on this asset, so 15% is required return. So this is return R. Then how much should the stock be selling for? So what is the price of the stock? And then P0 equals next dividend divided by required return minus growth rate of dividend. But in this problem, we know the dividend just paid dividend. So right now D0 is paid. So, but we know the dividend next year at time 1, the next time dividend. So we have to increase this by growth rate G. And here D0 is given by $0.5 times growth rate G is 2%. So 1 plus 0.02 divided by our required return 15% minus growth rate. So it is, this number 3.92 is the price of the stock. So you should be careful about the time of payment of the dividend. Let's solve another example. It is about the same dividend growth rate model. Suppose a company is expected to pay a $2 dividend in 1 year after 1 year. So this is D1 after 1 year. And the dividend is expected to grow at 5% per year. So this is the growth rate of the dividend. And the required return is 20%. So required return is the interest rate. Then what is the price of the stock? But again, it is simple. The price is the next dividend divided by required return minus growth rate of the dividend. But here, the next dividend is given by $2 and required return 20% and growth rate 5%. So we have this answer. So here, we did not multiply 2 by 1 plus growth rate because already $2 is the dividend next time after 1 year. So we do not multiply 1 plus growth rate in this example. And this chart shows the relationship between stock price and dividend growth rate. But it is very simple. The price of a stock equals dividend next time divided by R required rate minus growth rate. So we now look at the relationship between the stock price and dividend growth rate. And there is a positive relationship between stock price and dividend growth rate because it is in the denominator, so inverse relationship, but this is minus. So inverse is positive relationship. So as growth rate increases, the stock price would increase. In this example, the first dividend is given by $2 and required return 20%. And we change this 20% minus. So we change the growth rate and from 0 to 20%. As you know, required rate should be greater than growth rate always. So the maximum of growth rate should be 20%. But anyway, there is a positive relationship between the stock price and the growth rate of dividend. Again, we have the same numbers as before, but here we're going to look at the relationship between the stock price and required return. But here, the first stock price is given by $2, and we change, sorry, this is not growth rate, required return, R, required return, and growth rate is given by 5%. So there is an inverse relationship between interest rate, required return, and the price of the stock, because R is in the denominator. And R should be greater than this number, so $5% here. So minimum of R is 5% here, and the stock price would decrease as the growth rate increase. Sorry, this is not growth rate, this is required return. So the stock price would decrease as the required return R increases. Okay, let's solve another example. It is a little bit simple example. A company is expected to pay a dividend of $4 next period. So this is next dividend. So D1 is $4. And dividends are expected to grow at 6% per year. So this is dividend growth rate. And required return interest rate is given by 16%. And then what is the current price of the stock? It is simple. The next dividend divided by R minus G. So price is $40. Okay, this example is the same as before here. And what is the price expected to be in year 4? So we're going to calculate the price after 4 years. But at time 4, we're going to calculate the price. So the price at time 4 is simply the next dividend at time 5 divided by R minus G, right? So we have required return and dividend growth rate already, but we have to calculate D5. But we know D1 is given by $4. So D1, D2, D3, D4, and D5. We're going to find the next dividend, but from time 1 to time 5, there are 4 time intervals. So dividend D1 would grow 4 times, 4 years. So D5 equals D1 times 1 plus growth rate for 4 years from time 1 to time 5. So D1 is given by $4 and growth rate 6% per year for 4 years, and required return 16%, growth rate 6%. So we have this answer. The price at time 4 is this number. And here there is an important relationship here. The price is assumed to grow at the same rate as the dividend growth rate. This is very important. I will explain. The price at time t, and let's look at the price at time t plus 1. Then if we multiply 1 plus growth rate of dividend, then it is the price at time t plus 1, the next time. So the price of a stock would grow at the rate of G, the same growth rate of dividend. This is important. So we can prove this one. So let's think about the price at time 0 and the price at time 1. And as you know, I want to write down this like this way. Price at time 0 equals dividend at time 1 divided by R minus G. And the price at time 1 is dividend at time 2, next dividend divided by R minus G. I want to calculate a special rate. It is called capital gains rate. We already have this concept. Capital gains rate is next price minus current price divided by current price, right? Do you remember this formula for the capital gains rate? So just plug these formulas here. So P1 is D2 divided by R minus G, minus P0 is D1 divided by R minus G, divided by P0 is D1 divided by R minus G. Then simply this is D2 minus D1 divided by D1. You can cancel out R minus G, the same common denominators. But as you know, D2 equals D1 times 1 plus G. This is D1 plus D1 times G. So D2 minus D1 equals this minus D1. So cancel out D1. So we have D1 times G. So this is D1 times G divided by D1. So we can cancel out D1. So we have G here. So actually, capital gains rate, this one equals G. And this is the same relationship as this one. So Pt plus 1 minus Pt divided by Pt equals G. You can check this one. And this rate, capital gains rate, is the same as dividend growth rate. So this is important. I'm going to mention this again later. Okay, let's consider a little bit more complicated case, non-constant growth rate. So let's look at a simple example here. Suppose a company is expected to increase dividend by 20% in 1 year. So we consider the growth rate for the first year G, but G1 is 20%. And then next, G2, another different growth rate in dividend, 15%. So this is different growth rate for the second year. So dividend would increase with different rate, different growth rate. And after that, after 2 years, dividend will increase at a rate of 5% infinitely many times. So this is constant growth rate after year 2. And if the last dividend was $1 and the required return R is 20%, and then what is the price of this stock? So last dividend means that D0 is $1. Last dividend means that the dividend paid right before the current time. So if we assume that the current time is 0, then the dividend D0 is paid right before the current time 0. So last dividend means actually the dividend right before the current time 0. So, but anyway, we're going to calculate the present value, the price of future cash flows, not including this $1 last payment. It is already paid to somebody, and a new owner would purchase a new stock, then the new owner would get dividend from time 1. But anyway, we're going to calculate the present value of all expected future dividends. But here we have 1 to 3 different growth rates. So let's draw the timeline again. And $1 is just paid. So D0, $1 is just paid. And then the new owner of the stock would expect dividend at time 1, but the growth rate is very high, 20%. So we can calculate the dividend at time 1, D0 times 1 plus growth rate for the first year, G1, and G1 was 20%. So this is the dividend at time 1. And then the dividend at time 2 is D1 times different growth rate, G2. And G2 was 15%. And D1 is this number. And this is actually D0 paid right before. So D0 was already paid right before the current time 0. So the new owner of the stock would not get this last payment of the stock of the payment, the dividend at time 0. But actually, the dividend paid right before time 0. But anyway, D1 is D0 times 1 plus G1, and D2 is D1 times 1 plus G2, and D3 is this one, but the growth rate is D2 times 1 plus constant growth rate, and D4 is D3 times 1 plus G, the same growth rate, and so on. So D3 is D2, this number, times 1 plus constant growth rate, 5%, and so on. So from time 2, we have constant growth rate G. So we know how to calculate the perpetuity or constant growth dividend model. So at time 2, we can calculate the price of stock, but we need the next time dividend, D3. So D3 divided by R minus G is the price at time 2. So be careful about this time and this time. Here we have D3, R minus G, so this is constant growth rate. So we have this stock price at time 2. So we can calculate the present value of all future cash flows at time 0. So we discount this 1.2 D1 for 1 year. And at time 2, we have this dividend amount 1.38 dividend at time 2, plus we have this price at time 2. So we have this present value at time 0 here. So this is D1, and this is D2, and this is price, future value of the stock at time 2. So like this way, if we have multiple growth rates, then we have to calculate multiple cash flows in future time. And then after some time, we have constant growth rate. So at the time, we calculate the future value of stock using this constant growth pricing formula. Okay, here we have a very simple quiz. So let's solve this one very quickly. What is the value of a stock that is expected to pay a constant dividend of $2 per year? So this is constant dividend. If the required return is 15%, so this is R, required return. But this is very simple. It is dividend divided by required return. So $2 divided by required return 15%. So 13.33 is the price of the stock. Okay, let's solve the second problem. What if the company starts increasing dividends by 3% per year? The growth rate of dividend is 3%, beginning with the next dividend. So beginning with the next dividend means from D1, the required return stays at 50%. So this is required return. But we know that the price of a stock at time 0 is simply D1 divided by R minus G. But here, the dividend is increasing with rate 3%. So the current dividend is $2, right? And it will increase by 3%. $2, 1 plus 0.03, 3%. So $2. So here we have $2 dividend divided by and 1 plus growth rate 3% divided by R minus G. So here R is given by 15% and G growth rate is given by 3% and $2 initial dividend and growth rate 3%. And then we have the answer 17.17. Okay, we'll continue the lecture very soon. Let's stop here for a moment. I will continue soon.